Let's see the effect of change of concentration with the Chatelier principle. Consider the following equilibrium reaction. Nitrogen with oxygen gives nitrogen oxide. At the equilibrium conditions, the reaction mixture contains both the reactant and the product molecules. That is, nitrogen and oxygen will give nitric oxide. The concentration of reactants and product molecules are constant and remain the same as long as the equilibrium conditions are maintained the same. If a change is imposed on the system by purposely adding nitric oxide into the reaction mixture, then the product concentration is raised. Reactants is here, products is here. So the system possesses equilibrium concentration of reactants and products. So the excess amount of nitric oxide reacts in the reverse direction to produce the reactants, and this results in increase in the concentration of nitrogen and oxygen. The excess concentration of nitrogen and oxygen favor forward reaction, and the concentration of nitric oxide is raised in the reaction mixture. In general, in a chemical equilibrium, increasing the concentration of the reactant results in shifting the equilibrium in favor of the product, while increasing the concentration of the product results in shifting the equilibrium in favor of the reactants. Now let's talk about the Chatelier principle with the effect of change of temperature. So a chemical equilibrium actually involves two opposing reactions, one favoring the formation of product, the other favoring the formation of reactants. If the forward reaction in a chemical equilibrium is endothermic, absorption of heat, then the reverse reaction is exothermic, the evolution of heat. Let us consider the example nitrogen tetroxide, which will give nitrogen dioxide. So it's an equilibrium position. In this equilibrium, the reaction of the product formation is endothermic, so the reverse reaction nitrogen tetroxide is exothermic. If the acquired equilibrium reaction mixture is heated, then its temperature will be raised. According to Chatelier principle, the equilibrium shift in the direction which tends to undo the effect of heat. So I got the reactant, the heat is absorbed to give the product. The equilibrium will shift towards the formation of nitrogen dioxide, and subsequently dissociation of dinitrogen tetroxide increases. Therefore, generally, when the temperature is raised in a chemical equilibrium among the forward and reverse reaction, then more endothermic reaction will be favored. Similarly, if the temperature of the equilibrium is decreased or cooled, then the exothermic reaction among the forward and reverse directions of the equilibrium will be favored.